Hey guys, missed you last week. Hopefully you missed me too while you were doing all your work on your own and couldn't ask for help. Lots of you sent me your scores, pictures of your work, and did your IXL. If there's one thing that's going to be really important over the next little while, it's being self-motivated and staying up with your work. So if you haven't done what you were supposed to do last week, you really need to make sure you get that done and you get it sent to me because I'm going to be updating Jupiter grades all the time. For today's lesson, you're going to need your Chapter 9 journal, your Chapter 9 homework book, some type of paper, and a pencil. We're going to start off with some mental math. You're going to give yourself about 10 minutes to work on the questions while you pause the video, and then I will come back and go over them with you. There are 10 questions. Here they come. The reason that we're working on these mental math questions is because you have to be able to do these type of questions for your exam this year, which may or may not happen, but I want us to be prepared just in case it did. So this question takes us back to our Pythagorean theorem unit where we were looking at squares and square roots. So we're trying to figure out where the square root of 30 fits on a number line. So I know here that I've got the square root of 30 here, and I'm trying to figure out exactly where this is going to be. So I got to find the closest square roots to this number. Well, I know that the one that's smaller is going to be 25, which is 5 times 5. And I know that the next bigger one is the square root of 36, which is 6 times 6. So it's asking me what are the two whole numbers that would be between. Those numbers are going to be 5 and 6. All right, here we're trying to figure out the value of a square when we know that the value of each of our stars is 6. So I know that each star is worth 6, which means that this whole side is worth 12. Now, because things are balanced, I know that this whole side has to be worth 12 as well. Because that's worth 12, and it's split into 2, and these parts are balanced, I know that this is 6, and this is 6, which means that each one of those triangles is worth 1, and each one of these squares is worth 2, so there's your final answer. All right, here we have a question. This is the perfect kind of question for us to do at our whiteboards, but unfortunately, because of social distancing, you can't work with anybody else or you're stuck all on your own. So I have 4.5 pizzas here, and I need to share them with 9 people. So I got to figure out what the best thing to do is. And because I don't know how to divide fractions, all I'm going to do is I'm going to split each one of them in half. And now I'm going to give half to each person. 1, 2, 3, 4, 5, 6, 7, 8, 9. Each person gets half a pizza.
But I want more.
Side length. And I know that when I'm trying to find side length, when I'm given the area, I'm trying to find what number times what number equals 81. And let's remember that these little marks here mean that the length and the width are both the same. So I'm trying to find a number multiplied by itself that gives me 81, and I know that that number is 9, so my answer is 9 meters. Well, we have not learned how to do this type of question yet, so I'm guessing some of you tried to do this one by guess and check. Hopefully you came up with 13. Have a look at how I did this. If you don't know how to do it now, don't worry. This is chapter 10, and hopefully we'll all be back together then. Oh, this is perfect timing for this kind of question. We've got what we call a function table here. We're going to start looking at function tables today for the beginning of chapter 9. So we have one adult, and 4 children. That is 5 people. If I had 2 adults, I would have 8 children, which would be 10 people. If I had 3 adults, I would have 12 children, which is 15 people. That's what I'm looking for. So I've got 3 adults and 12 children.
Woohoo! Children win!
Well, the title slide for our video today said Math with the Maskiws, so I've brought Mark along today to help us out.
Hi,
so that we've got a little bit of help. So what I need you to do right now is have your journal on page 8, and I also need your homework book on page 476 so that we can have a look at how to describe patterns. So these notes are going to go in your journal. Right now we're going to take a look at how to describe a pattern using words. So, Mark, help us out here.
Yeah.
We've got this pattern here. What is it, Mark? What are those things? 10, 20, 30, 40.
They're numbers.
Yes, so you're going to write down numbers. Where do they start?
At 10.
Starting at 10. And then what happens to them, Mark?
It increases by 10.
Perfect. So it increases by 10. So what you're doing when you're describing a pattern in words is you are saying what it is, could be numbers, could be shapes, where it starts, and how it changes from there. We have example number 2 here. This one we're not going to write down in our journal. We're just going to work through this one. So it says describe a pattern in words. Same thing. So we've still got those 3 bullets. So we got to think about what 3 things we're going to write down. Mark, what are those? So those are numbers. Good. Where do they start? So it starts at 2, and then what's happening to those numbers, Mark? All right, so each time the number is doubling. So Mark, could you tell us what would be the next number in the pattern? 32 would be next. What would come after that? 64. All right, thank you. Well, now we know how to describe our pattern in words. It's time to put it into something useful. So we're going to learn how to put it into what we call a function table. So show patterns in a table. You can copy this down in your journal while I'm talking. So I've got figure 1, figure 2, and figure 3. When we finish with these 3 figures, we're gonna predict how many seats there would be in figures 4, 5, and 6. All right, so I've got a table and I've got 4 seats around it. So in figure 1, I have 4 seats. If I go to figure 2, I have figure 2, and if I count the seats around, I have 1, 2, 3, 4, 5, and 6 seats, which is interesting since I doubled the amount of tables, but I didn't double the amount of seats. Now, when I go to figure 3, I now have 8 seats around it. So I only have 8 seats. So if we think a little bit about why that is, that's because we keep adding people on the side of the table, but we can't add people to the middle. So it's not doubling. Now, if I were to have a 4th figure, I want you guys to think for a minute how many seats there would be. Well, what we're seeing is that we're adding 2 each time, so it would be fair to guess
10.
that if we had 4 tables, we would have room for 10 seats. We're going to take a look now at how to take that function table and make an expression out of it. So we got to know that an expression does not have an equal sign. So we're just looking for what we do 2x in order to get to y. So we have to get out of the habit of looking vertically here and looking from y down, looking at the 10, 20, 30, 40 pattern. Instead, we need to be looking at how to get from x to y. So Mark, why don't you show us how to get from x to y in the first one?
So one times 10 is 10, and then 2 times 10 is 20. So your answer is 10x.
Perfect. So we're going to write 10x instead of writing x10. We just want to get into that habit. We don't want to say x times 10. We want to say 10x. How about the second one, Mark?
So this one, so 2 times what equals 8? It's 4. 3 times 4 is 12. So you know that your answer is 4x.
Thank you.
I
All right, so we've got a little bit more complicated questions here this time. So I've got 1, 2, 3, and 4. Now I've got 4, 7, 10, and 13. So what are you thinking when you look at this, Mark?
I think you add 3.
Okay, so you're just adding
Every
3
time.
each time. Absolutely. So we're just going plus 3, plus 3, plus 3. That works great. But what are we going to do when we get to something like 40? So I need us to come up with an expression that's going to help us answer any one of these questions here. So what could we do each time to get from x to y? Let's try a few things.
4 doesn't go into 13. 3 doesn't go into 10. 1 goes into 4.
Okay.
And then 2 doesn't go into 7.
Okay, so we've got the simple things don't work, right? Okay, so let's see if we can look really closely at it, somehow using this 3 to help us out, because that has something to do with the right answer.
Okay, so I'm wrong.
So far. We'll figure it out. Mark, how could we get from 1 to 4?
You could add it by 3.
Okay, so we could add it by 3. Does that work if we try to go from 2 to 7? It doesn't. Okay, so that doesn't work anymore. What if we tried times 4? 1 times 4.
That's 4.
Okay, what's 2 times 4? So that doesn't work for 7 either. Okay, let's keep trying.
What do you guys think?
Okay, take a look and tell us what you need to do.
I think that you need to times it by 3, because 2 goes into 6, and then you add 1. And 3 goes into 9 3 times, and then add 1.
So is that going to work every time?
I think.
All right, so if we're going to write it as an expression, what's it going to look like?
I think it would be 120. Oh, wait, no. 121.
All right, so I think what you're looking at is you're doing 3x, which is 3 times x, plus 1.
Yeah.
So there's our expression. It'll work every single